So, you're thinking about buying a 60 cubic meter per hour concrete batching plant. That's awesome. It's a massive piece of engineering, like a giant, super precise kitchen for construction sites. And getting one is a huge step. But here's the thing, it's not like buying a power tool. There are hidden details and engineering traps that can turn a big investment into a big headache. I've spent years in this industry and I've seen it all. Plants that promise 60 but deliver 40. Mixers that break down constantly. Control systems that look like they're from 1985. It's a jungle out there. Okay, first up, and this is the big one, plant capacity. The spec sheet says 60 cubic meters per hour. But is that a best-case tailwind number or real output on a messy site? Dig into duty cycle assumptions. Manufacturers often assume a perfect non-stop loop. In reality, weighing, cement loading, mixing, and discharge times all add up. Ask for the detailed cycle time calculation and challenge assumptions. What's the mixing time used? And is it realistic for your concrete quality? Demand proof. Review reports from previous installs, but read the conditions, not just the final number. Aggregate moisture, mix designs, site setup all matter. Best of all, visit a similar running plant. Time full cycles yourself. Measure output over an hour. A reputable manufacturer will be proud to show performance. If they hesitate, that's a red flag. Now, the heart of the operation, the mixer. First, confirm the model. Twin shaft, planetary, or pan. Each has its place. Twin shaft is the workhorse for high-volume standard concrete. Planetary delivers more homogeneous mixes, critical for precast and high-performance concrete. Match the mixer to your product. Inspect reliability details, mixing arms, paddles, liners. What are they made of? Cast Nyhard or basic hardened steel. That dictates downtime frequency. Ask for a load test. Watch motor amperage and RPM. You want a smooth, powerful hum, not a struggling groan. This component works the hardest, built like a tank. A concrete plant is a high-speed logistics puzzle, moving rock, sand, and cement from storage to the mixer with precision. Skip hoist is compact and cheaper, but can bottleneck throughput. A chevron belt conveyor feeds continuously and shortens cycle time, key to hitting 60 MER3H. Verify conveyor tons per hour rating. Inspect belt quality and rollers. These wear items can cause misalignment and downtime. Check silo capacities. Aim for at least 1 full day of peak production. Assess screw conveyor sizing. An undersized screw slows batching. Demand calibration certificates for scales and load cells. Keep cement in the mix, not the air. Look for bag filters in silos and shrouds at transfer points. You've covered the muscles, now the brains. Is the PLC from a reputable brand? Industrial-grade hardware is reliable and serviceable. A clear touchscreen HMI makes operators faster and reduces errors. Avoid confusing button jungles. Modern systems need robust recipe management and easy adjustments, switching mixes on the fly without hassle. Ask about full data logging, every batch, weight, and alarm for QC and troubleshooting. Demand remote diagnostics. Remote access can save days of downtime. Power drives profitability. A 60 MER3H plant is power hungry. Large motors run mixers, conveyors, and compressors. Get the total connected load, but prioritize actual consumption in kWe per cubic meter. Efficient motors and gearboxes cut running cost every batch. What happens when the grid drops? Verify voltage phase, size a generator for inrush current, and ensure easy grid-to-genset switching. Engineer around flickers. Protect batches with proper backup design. Storage and accuracy rule consistency. Are aggregate bins large enough to buffer supply hiccups? Check steep valley angles and smooth walls to prevent bridging. Damp sand and sticky aggregates can clog and delay. Batching accuracy is critical. Demand guaranteed tolerances. Cement plus 1%, water plus 1%, aggregates plus 2%, with calibration certificates. Look for in-flight compensation. The software closes gates slightly early to hit target weights precisely. That's pro-grade engineering. Even the best machines need service. Investigate the service network, local technician availability, and guaranteed response times, because downtime is expensive. Get a critical spares list and lead times. Local stock beats overseas shipments. 2 weeks for a critical part is unacceptable. Review warranty scope and duration. Ask for comprehensive operator and maintenance training. Trained teams prevent problems and fix small issues fast. A well-designed plant is a safe plant. Verify guards on moving parts and clearly marked accessible e-stops, then test them. E-stops should kill motor power instantly. Confirm dust collectors, spray bars, and enclosures, and documented noise levels that meet local ordinances. Ask if the manufacturer supports permitting with environmental and building documents tailored to your region. Can it fit and function on your site? Start with a proper foundation. These plants are heavy with dynamic loads. Get foundation drawings and soil-bearing requirements signed by a civil engineer. How transportable is it? Modular sections that fit standard trucks/freight complexity. Ask erection time, crew size, and schedule. Plan utilities and access, substantial water supply, correctly sized electrical service, and clear roads for modules, aggregates, and mixers. That's the complete 9-point inspection. Capacity, mixer, handling, automation, power, accuracy, support, safety, footprint. Good manufacturers welcome these questions and show proof. Use this checklist, be thorough, and buy the right plant for years of payoff.